Okay, we finished our test one. It was on chapters 1 and 2. Today we start sections 3.1 and 3.2. And we're talking about functions. First definition that we have is, what do we mean by the domain of a function? The domain of a function are the x values. Domain, x values. The range of the function are the y values. The x value can also be called the independent variable, which means we're going to plug in x's and get out y's in nearly all of our cases. The independent variable is also called the augment sometimes. I think that's probably the last time you'll hear me call that. Y is the dependent variable. Okay, get a couple definitions out of our way. An implicit function is a function that's written in this style. Okay. An explicit function is a function that's written in this style. Now, I want you to notice the two things that I just gave you there. They're really the same two functions. Now, look at that explicit function, because this is the style that you're going to put it in when you start putting it into your calculator and letting your calculator draw the graph for you. One of the things that we're still going to be talking about when we're talking about function is the intervals that we're going to be working on. So this thing is written in the style of x greater than or less than. If I'm going to write that as an interval, we're simply going to say -8 and 5. Now, I want you to notice that the parentheses goes with the -8 because it's not included. The bracket goes with the 5 because it says that it is included. Now, if I just give you a set of numbers, and I say, these are the points that we're going to plot. The first question would be, what is the domain? Well, the domain is exactly what it shows. We set up here the domain of the x values. So the domain of this function then is going to be 3, 7, and 6. The range of the one that I just gave you are going to be 4, 9, and 8. It's that simple. Let's make it complicated. Now, the big deal is it a function or is it a relation? I think the easiest way to remember it is this. If it's a function, the x's can't repeat. I'll say it again. If it's a function, the x's can't repeat. So if I give you this set, that thing is not a function. It's a relation, and it's a relation because the x's repeated themselves. A good way to think about it is this. If you plotted those points, 3, 4, 3, 5, 3, 8, I want you to look at it. You would get a vertical line. And we're going to talk about that vertical line. I think some of you might remember from your Algebra 2 or Advanced Math, the old vertical line test, but we'll get to that a little bit later. We could also look at it from an equation standpoint to decide if it's a function. If I give you y is equal to x plus 6. And the question is this a function or it's a relation? Well, if it's a function, because each time I put in an x, I get out a new y. In other words, the x's are not going to repeat themselves. So this would be a function. But watch if we change it, just this simple right here. X is equal to y squared. Show you what I'm talking about with just put in one and get out another one. In this particular case, if I let x be 1, so I got 1 is equal to y squared. To solve this, you're going to take the square root of both sides. But the square root of 1 is either plus or minus 1. So what that says is, when I put in 1, I got y could be 1, or if I put in y, 1, y could be minus 1. Now, look at it on the graph. To me, a picture's worth 1,000 words. So here is 1, 1, and here is 1 minus 1. Now, we're going to go ahead and follow up to this thing because 0, 0 is also a point. I want you to look at this graph. Now, that graph says that this thing is not a function, but it's not a function because my ones repeated themselves. I had a plus y and a minus y. And let's just do a little bit of review right here. The line of symmetry for this particular graph is the x-axis. That splits it halfway in two. So if I give you y is equal to x cubed, oh, by the way, this thing right here, as we said, not a function. It's not a function because the x's repeated themselves. Now, y is equal to x cubed. You might as well get used to it. We're going to draw it a little bit more later on. But this is what we call a cubic function. In this particular case, 1, 1, 2, 8. Back down here, I'd have minus 1, minus 1. And I'd have minus 2, minus 8. So this thing is still a function. It's still a function because none of the x's repeat themselves. Now, be careful with one like this. That should be one that you're familiar with because that's one that we talked about before we took the last test. This thing is a circle. So if I draw the graph of this, forgive my sloppiness, but that's a circle, and the radius of that circle is 5. Well, we don't have to go any further than this right here. The 0 had a positive 5 with it, and the 0 had a negative 5 with it. Therefore, this thing is not a function. It is a relation. Let me give you a little shortcut. Every time you have y squared, it's not going to be a function because when you have y squared, you're going to have the fact that the x is going to repeat itself. In fact, it repeated here for 0, but we could take any other numbers that we wanted in there. Well, let's just take one. Let's let x be 3. So if I let x be 3, I got 3 squared plus y squared is 25. I got y squared is 16. I got y is the square root of 16. Y is plus or minus 4. So what that says then, I'll exaggerate it so we can see it. When x is 3, y was 4. But when x is 3, y is also minus 4. In other words, it's not a function because the x repeats themselves. Had 3, 4, and also had 3 minus. Okay, let's get used to something that we call function notation. Let's do a simple one first. Function notation is just a fast way or simple way of saying the same thing that we've been saying. This is the same thing as saying y is equal to x plus 3. So if I want f of 1, it simply means everywhere I got an x, I'm going to plug in a 1. So I put in 1 for x, and I got out 4 for y. That's how simple function notation is. If I put in an a for x, then I get a plus 3. So when I put in an a, my y value was a plus 3. You put in x's and you get out y's. Let's look at this thing right here. What is the domain going to be? Well, this is first degree in x. That's going to be a slanted straight line that says I can put in any x I want and I get out a y. So the domain is all real numbers. Course compass may well write the domain like this. It goes from negative infinity to positive infinity. On this particular line, we've got the same thing. The range is going to be all real numbers because the range can be any y value from positive infinity to negative infinity. But we can limit the domain. We can also limit the range. In fact, I think one of the easiest ways is to back up and look at what we just did. All right. This is going to be a circle with a radius of 6. And boy, you're going to have to stretch your imagination to call that a circle, but we know where we're going with this mess. Now, I want you to look at it. The smallest x value that we can use is -6. The largest x value that we can use is +6. So the domain of this thing is going to be -6 is less than or equal to x is less than or equal to 6. And in this particular case, the range is going to be -6 is less than or equal to y is less than or equal to 6. The domain and the range for the circle there is the same thing. You can also limit it, and we need to get used to this one right here. This is what we call the absolute value function. So let's do this simply by plotting some points. If I let x be 0, when x is 0, the absolute value of 0 is 0, and 0 plus 4 is going to give me 4. Now, when x is 1, I get 5. When x is 2, I get 6. So, and that's a straight line, by the way. It's not supposed to be wavy. But watch what happens here. When x is -1, I still get 5. And when x is -2, I still get 6. So look at that. Every time we have the absolute value first degree, we're going to get this V-shaped curve. Well, I think we can see that this thing right here, the domain, I can put in any x's that I want. So the domain is going to be from negative infinity to infinity. But here's a case where a picture's worth 1,000 words. The range, look at it, the lowest y value that I had. So the range of this mess is going to be y is greater than or equal to 4. So if you want to put it in interval notation, it would be from 4 to positive infinity. Another way that we can have a restriction on the domain is to use different powers. So let's say that f of x is the square root of 3x plus 2. Well, number one, when I have taken the square root, I can't have a negative. The whole mess underneath the radical can't come out negative. So the first thing I got to do is ask myself, what will I have to use to make the stuff underneath the radical greater than or equal to 0? Well, it's a linear inequality. You simply move the 2 over, and x is greater than or equal to -2/3. So that means the domain of this thing starts at -2/3, and it goes to positive infinity. Now, that's a big help. And if you draw the graph, and your calculator will draw the graph of this thing, I want you to watch what happens to it. At -2/3, the y value is 0. Now, if I let x be 0, I've got the square root of 2, which is 1 point something. So this graph is going to look like this. But look at the graph. It shows you that the x is starting at -2/3, and you keep on using x and keep on using x's. Now, in this particular graph, I want you to look at the picture. Y is greater than or equal to 0. The lowest y value is 0. All of these other y values are going to be positive. So my domain was limited by what's underneath the house. It has to be greater than or equal to 0. And then my range, we can see from the graph that all the y values are going to be positive. Okay, another concept. If I tell you that f of x is equal to x plus 5, and I tell you that g of x is equal to 2x plus 3. The question is, what is f plus g of x? Well, don't make it complicated. You're simply adding the two things together. So x plus g of x would be x plus 2x, which is 2x, and 5 plus 3 would be 8. And you could do the same thing if you subtracted them or if you multiplied them. Now, an interesting thing, and this is something that's very, you have to be real careful with. If in general, if I tell you that the domain of some function is from 0 to 5, and I tell you that the range of that same function is from 3 to 8. But if I want the domain, or let's see, if I tell you the domain of one function is 0 to 5, and I tell you that the domain of another function is from 3 to 8. So the domain of the f function is 0 to 5. The domain of the g function is 3 to 8. Personally, the easiest way for me to realize that and to show that is simply this. On that f function, my domain was from 0 to 5. Now, on my g function, my domain was from 3 to 8. So on the g function, the domain was 3 to 8. The domain of f plus g is where they intersect. The domain of f plus g is going to be from 3 to 5. Look at it carefully. The domain of the f function was 0 to 5. The domain of the g function is from 3 to 8. The domain of the combination of f plus g is where they overlap, and that is from 3 to 5. Okay, I'm going to put you a special note by this next thing that we're fixing to do. You're going to see this, and particularly if you take a higher math, you're going to see this. And this thing is called the difference quotient. The difference quotient simply says f of x plus h minus f of x divided by h. Okay. I want to let the cat out of the bag. What it really says is that I've got the slope because of f of x plus h is one point on the graph, f of x is another point on the graph, and down here, if I had x plus h minus x, then I end up with this x. So this is just a fancy way, and I want you to put it in your mind. It's a fancy way of talking about the slope. Let's do it for a reasonable one to start with. Okay, my function is f of x is equal to 3x plus 4. Well, we know that when something is written in this form right here, the number in front of the x is the slope. So for this particular problem, before we even work the mess out, my slope is going to come out to be 3. Now, drive carefully with this. So this is my function. This is f of x. I want f of x plus h. Well, that says that I replaced my variable with this right here. And this is x plus h. So that gives me 3x plus 3h plus 4. Now, f of x he gave to me is 3x plus 4. The formula up there says that we're going to take f of x plus h, which is 3x plus 3h plus 4, and we're going to subtract f of x, which is 3x plus 4, And we're going to divide all this mess by h. Well, let's look what we got. This right here is f of x plus h. And this is f of x. And I want you, very important that I put that minus sign in there. Now let's do the arithmetic. Well, the first thing, when I drop the parentheses, I get 3x plus 3h plus 4. Now this has a negative in front of it, so that's going to give me a minus 3x and a minus 4. And all of this is divided by h. Now watch the arithmetic. Plus 3x minus 3x cancels out. Plus 4 minus 4 cancels out. So I got 3h divided by h. Now, most people say, hey, that's 3. And that's right. But in order for it to be 3, you have to tell me that h can't be 0, because we've already talked about that. You can't divide by 0. So if h is not 0, then I got 3h divided by h, and I can cancel it out. So this thing does become 3. Boom. Remember what we said a while ago? The slope of this line is automatically 3, because that's what my equation told me that it was going to be. And my difference quotient gave that to me. Now, the big deal on this is that look back at the formula, and it talks about f of x plus h. Well, so x plus h is a different point from x. So that means that h can be very, very, very small. And that's going to be very, very, very important when you get to it in that calculus class and you start talking about the first derivative. In fact, that's really what we just did. Okay, that pretty well takes care of section 3.4. 3.2, we're still talking about functions. I want you to keep in mind that a function can have only one y-intercept. I repeat, a function can have only one y-intercept. So that gives us what I hinted at a while ago, the vertical line test. So if I just draw your graph, any old graph, and I draw that graph there, does it pass the vertical line test? And the idea is this: if I can chop this up, every time I draw a vertical line, it only hits my graph one time. Everywhere I drew that vertical line, it only hit my graph one time. So it passed the vertical line test. Now, remember that graph that we drew back there a while ago? We drew this thing. This is my graph. This is my f of x or g of x or whatever you want to call it. But when I draw a vertical line through it, it hits the graph up here and it hits the graph down here. So this thing is not a function. It's not a function because it doesn't pass the vertical line test. Well, I think you can see automatically that every time we drew one of those circles, it's going to fail the vertical line test. It's not a function. The vertical line test is very important because if I got the graph drawn, in fact, in many cases, you're going to draw that graph with that graphing calculator and it's going to be there for you. And you can see real quick, like whether or not it is a function. Some of those others that we drew, for instance, this one right here was y was equal to x cubed. Well, you chop it up with vertical lines, and every time you draw a vertical line, it's only going to hit that graph one time. So this thing is definitely a function. Now, I'm going to put this down, and we're going to also use this in the next section when we get to that 3.4 and 3.5. So I'm not going to give you an equation. I'm just going to give you a bunch of points. Okay, this is minus 6, minus 3. I got minus 3 and 0. I got 0 and 3. And Let me make sure I get my points right. I got a point up here called 2, 4. I got a point over here that I'm going to call 4, 3. And then a point down here is going to be 5, 0. And then I got a point over here I'm going to call 8 minus 2. And then this is 10, 0. This is 11, 1. Now I want you to notice I haven't given you a formula for this thing. In fact, I doubt that it has a formula. Okay. Something that we need to be aware of. If I show you that I'm starting this thing at minus 6, minus 3, and I'm ending this thing up here at this 11, 1, that's going to play a big part in how we're going to answer some of these questions. Okay, he gives you that graph. And then he asks a question like this. F of 0 is equal to what? Well, you look at your graph. When x is 0, y is 3. So that means when x is 0, y was 3. If he wants f of 4, well, f of 4, you look at your graph again. When x is 4, y is 3. If he wants f of 8, look at your graph. When x is 8, y is negative 2. So we're reading it straight off of the graph. Suppose that I tell you that f of x was equal to, let's say, 1. Then how would you answer my question? If f of x is equal to 1, well, look at the graph. The graph says when the y value is 1, the x value is 11. So the answer to this thing is x is equal to 11. Okay, then he's going to ask you this question. What is the domain of this function? Well, we said the domain is a set of x values that we use. Now, the fact that I drew this line between all of these points means that all those points in there exist, even though they're not labeled. So the domain of this thing, the first x value is minus 6. And then the last x value over there is 11. Now I'm using brackets because the minus 6 is included and the 11 was included. Now be careful with the range of this mess. You look at your graph. The lowest y value on this graph is minus 3. The highest y value on this graph is plus 4. So the range of this graph is from minus 3 to plus 4. And we got that answer simply by looking at the graph itself. Let's answer another question. On this graph, I want to find the x-intercepts. Well, the x-intercept is where it crosses the x-axis. So the first place it crosses is at minus 3, 0. The next place it crosses is at 5, 0. And the next place it crosses is at 10, 0. Now, we got a little problem here. And that was one of the problems that I found on grading y'all's test. I beg you, before you take this next test, make sure you do homework and you check some of those homework answers to make sure that you're writing the answer the way Course Compass is going to write the answer. In this particular problem right here, he did not write it as an ordered pair. He simply says that you're going to say that the x-intercepts are going to minus 3 and 5 and 10. Now, I beg you, make sure that when you're doing your homework, you're doing your quizzes, that you try to learn to write the answer in the manner that he did. But of course, on the test, I'm going to grade every problem that you missed. And in most cases, I found this was the error. particularly with this case of intercept. You wrote it as an ordered pair. He simply wanted it as an answer. Okay, let's stick with this function notation stuff. This is my function. This is my graph. And he asked this question, is minus 1, 2 on the graph? Well, how are you going to answer that? The way is simple. He says put in minus 1 and see if you get out 2. So F of minus 1 is going to be 2 times minus 1 squared minus 1 minus 1. So this is going to be 2 plus 1 minus 1, which is going to be 2. So when I put in minus 1, I got out 2. So the answer to the problem is yes, it's on the graph. Get used to that idea of putting in x's and getting out y's. Now, be careful with what he asked for here. Okay, so look what this problem says. He's telling you that the y value is minus 1. So f of x is minus 1. So minus 1 is equal to 2x squared minus x minus 1, because that was the equation that we had right here. So minus 1 is 2x squared minus x minus 1. Now, we go back to the second lesson of the second day of class. This is a quadratic equation. We're going to put everything over here on the right side, simply because that's where the biggest number in front of the x squared is. So minus 1 here cancels out with minus 1, and I get 2x squared minus x. Now, I know I sound like a hung up record, folks, but I told y'all ahead of time, this is a type problem that too many people miss. And you shouldn't miss this thing, because to solve it, you're going to take out the common factor of x. And that's going to give you a 2x minus 1. Now, you use your rules. The first thing is 0. The second thing is 0. Well, this says that 0 is one of the answers. This is a linear equation. You're going to bring the 1 over. And this says that x is equal to a half. So it was quadratic. It was supposed to have 2 answers, and I got my 2 answers. I got 0, and then I also get 1/2. He also asked for this particular function for the domain. Well, the domain of this thing, look at it. You can put in any x that you want. There's no restriction then, because there's no square roots. I don't have to worry about negative numbers. Nothing's going to make the denominator 0. So the domain of this thing is going to be from negative infinity to positive infinity. Now, I want you to notice that he didn't ask for the range, and he has a reason for that, because we haven't learned to draw that graph yet. Of course, you could cheat and put it in your calculator and draw it and see it, and you can see that the range is limited. In other words, it has a lowest y value. The next thing that he asked for, and I'm going to block it off here so I can keep it all in the same class, he asked for the x-intercepts. Well, on any graph, to find the x-intercept, you let y be 0. So I got 0 is equal to 2x squared minus x minus 1. Okay, this is something that we have hassle with, because we have trouble factoring when the number in front of the x squared is not a 1. But this one is not too bad, because the only factors of 2 are 2 and 1. And the only factors of 1 are 1 and 1. So I got an outside product and an inside product. My outside product is going to be 2x. My inside product is going to be 1x. I keep harping on this fact, and I can't overemphasize it. This middle sign goes with the biggest product. So that means the negative has to be here. Well, the only way I can get the negative there is to put the negative there. The fact that this tail end number is negative says they have to be opposite signs. So if I got a negative here, then I got a positive here. So this says then that 2x plus 1 is equal to 0. So this says that x is minus 1/2. And the other one says that x is equal to 1. So I got two x-intercepts. I got an x-intercept of minus 1/2, and I have an x-intercept of 1. Okay, a new function. Now I deliberately picked this one because we've got to think just a little bit more with this mess right here. Okay, first of all, we've got to talk about this thing of the domain. And this is one of your test problems. Look at this right here. What is the only value of x I can't use? Well, it's 6, because 6 minus 6 will make the denominator 0. So my domain is x is not equal to 6. Okay, I hope Course Compass will let you write it that way, but they might not. So they might say you go from negative infinity up to 6, and then you put that in union with 6 to positive infinity. I hope they don't make you write it this way, but check that answer to make sure. To me, it's so easy to simply say that x is not equal to 6, because that's the only thing you can't use. And then he asked some of the same question. For this particular problem, how much would f of 1 be? F of 1 would be 1 plus 2 over 1 minus 6, which is 3 over minus 5. So you put in the x and you get out the y. Now, suppose that he tells you to solve f of x is equal to 3. Well, he's telling you that f of x is 3. So 3 is equal to x plus 2 divided by x minus 6. Now, we got an equation that we got to solve. Well, my denominator is x minus 6, so I'm going to multiply the left side by x minus 6, and I'm going to multiply the right side by x minus 6. This cancels out. So this gives me 3x minus 18 is equal to x plus 2. So I got 3x minus 8 is 2 plus 18. So I got 2x is 20. So x comes out to be 10. Now, so it's that simple. He tells you what the y value is. You end up with the equation with a denominator, and you have to get rid of the denominator. Okay, he gives me a graph, and he says that this point over here is going to be the point 5, 2. And then I'm going to come over here, and I have this point is minus 5 and 2. And this point is 6 and minus 7. And this point back here is minus 6 and minus 7. Now, that's all he gives you. He simply gives you that graph. First of all, can't we look at symmetry? Look over here, I got 5, 2, and I got minus 5, 2. So the y-axis split that line half in two. I went from minus 6 minus 7 to 6 minus 7. But halfway between minus 6 and 6 is still the y-axis. So it has y-axis symmetry. Okay, and we can answer a couple more questions on this thing, the domain. Well, the first x value that I used is minus 6. The last x value that I used is positive 6. So the domain of this thing is going to be all the numbers between 6 and 6. And I repeat myself, every time you have the graph, you can probably figure out the range. Well, look at it. The lowest y value is 7, but the highest y value is 2. Therefore, the range of this thing goes from -7 up to 2. Again, the picture's worth 1,000 words. Okay, next question. Is it a function? Is it a function? Well, when we got the graph, we're going to use our vertical line test. Well, stop and think about it. If I draw a vertical line here, 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 every time I drew a vertical line for this thing, it only hits it one time. And the answer is yes, it passes the vertical line test. It is a function. Okay, we'll do one more. Or maybe two more. Now, this is a graph that some of you might remember from your Algebra 2 or maybe advanced math. This is my X and Y axis. This is my graph. First of all, this thing has some symmetry. Look at it. If you just folded this one over on this one, so it has Y axis symmetry. Also, if I fold it from top to bottom, it also has X axis symmetry. And believe it or not, this thing also has origin symmetry, because if I take this point and I take the corresponding point here and I drew the line between them, the origin would be the midpoint of that line. So it also has origin symmetry. Now, what it boils down to, the equation, if I put this point right here to be 3, 0, I'm making it up as we're going, then this is the equation for that graph that I just drew you. And I want you to look at it. It is squared in X. Well, squared in X says it has Y symmetry. It's also squared in Y, so that says it has X symmetry. And when it's squared in both of them, that means it has origin symmetry. So that just solidifies what we just got through saying, or knowing simply by looking at our two graphs. Okay, I hope these videos are going to work for you. This is the way we're going to do it the rest of the semester, because I only had 2 or 3 people that showed up each time to make those recordings. This way I can make them at my own time, and we still get, I think, the same thing done. Have a good day, and make sure that you remember that sections 3.1 and 3.2 will be due Sunday night.